here we go. Absolute value. So the other part that we need to remember is that we talked about this when we solved absolute value equations. Most absolute values have two solutions. Most of them, not all of them, but most absolute values have two solutions. Like if my absolute value answer, the answer to my absolute value is 4, there are two ways to get an absolute value of 4. I can have a positive 4, is the absolute value of 4, or I could have a negative 4 and have my absolute value answer be 4. So most absolute values, most solutions have two. Most absolute values have 2. Now let's look back just so that you can remember. What page were we on? Absolute value equations, page number 25. Remember when we had the absolute value problems, we split it into 2 problems. We had one positive and one negative. We did positive 30 and we did a negative 30 because inside this absolute value, I could have a positive value to make 30 or I could have a negative value to make 30. When there is an absolute value, most of them are going to have 2 ways of getting there. So keep that in mind as we're working through today. We are going to be graphing today. So the shape we are looking for, it is not linear. If you think about it, if most parts have 2 answers, they're going to be across from each other, right? They're going to have 2 answers. So the shape we're looking for, the graph makes a V. Because, if you think about it, if one of them, our X answer, is positive 2, the other would be negative 2. They're opposite each other. So there are going to be 2 pieces. One on one side, one on the other side, making a V. So the absolute value equation or formula looks like this. Absolute value formula. This is what our problem is going to come in the form of. Y equals, that means we're going to graph it, mx plus b. Does that look familiar? And then we sometimes have this thing out here called plus c. These values are going to be just different numbers, right? Or maybe they're not there. Maybe it's a 1, or it could be 0. So when we're graphing, we're making a V, right? That's our end result. That's the absolute value function, is this V. Do you know what this point right here at the very bottom, or maybe if it was upside down, would be called? What's that point called? What's the corner of a shape? Vertex. Vertex is an angular point. Vertex is that angular point. It's where it changes direction. It's the highest or lowest point. So that's where we start making our graph. We start making our absolute value graph by finding the vertex. We start by finding the vertex. And, not so shockingly, there's a formula we use. The vertex formula is, if it's a graph, it's got to be an ordered pair. Do you agree? The vertex formula is negative b over m. That's our x value, comma, c. So if you're given an equation, if you're given y equals, and then the math problem right here, could you use this to substitute into the formula? Right, you just identify. You identify the m, you identify the b, you identify the c. What if there is no c? What would you substitute? 0. What if there's no m? What would you substitute? 1. Right? This is what we're looking for. You find the vertex. Once you find your vertex, we're going to graph. Now, the graphing rules are a little wordy. I apologize. But we need those words to guide us through. So here we go, steps to graph. Steps to graph this. Find the vertex and plot it. Find the vertex and plot it. How do you find the vertex? Negative b over m is your x value. C is your y value. That's your ordered pair. Negative b over m, comma, c. You're going to find the vertex. You're going to do some algebra. Minimal algebra. It's just a division problem with a negative, right? Plot it. Then here comes the wordy part. So I'm going to write it first and really think about what we're writing, okay? You are going to pick an x value one space away from the vertex. You're going to pick an x value that's one space away from the vertex. Pick an x value that is one space away from the vertex. All right, so here's my graph. Let's pretend the vertex is right here. What is an x value that is one space away from the vertex? Joseph?
1 or negative 1.
I could either do positive 1, because that's one space away, right? Or I could do negative 1, because that's one space away. Me personally, I would pick positive 1 to avoid having to deal with a negative, correct? That would, in my opinion, be the best one. What if my vertex was right here? What is an x value that is one space away? What is an x value that is 1 space away. Phoebe?
-2 or -4.
I could do -2 as my x value because that's 1 space away. Or I could do -4. It's your choice. I would probably pick -2 because dealing with 2 sometimes is easier than dealing with 4. But if I'm making a V shape, think about what it's going to mean. Think about that, because you'll find it out in a second. Maybe it's going to go this way. But I want you to kind of have that in the back of your mind of what's going to happen. So you're going to pick an x value that's 1 space away from the vertex. Right or left. Doesn't matter. You have a little bit of freedom. Once you've picked that, you're going to substitute the value into the original equation. So if you pick 1, or you pick -1, doesn't matter, you're going to substitute it into the original equation. And you're going to simplify. What does it mean to simplify? What is simplify? Make it easier, combine it, do the math. You're going to plot this ordered pair. Because if you substitute an x value into the problem, if I put an x value in to my equation, remember my equation was up here? If I put an x value into my equation, what do I get out? If I put in an x value, what am I getting out? What's my answer? Y. If I put in an x, my answer, what I get out is a y. And an x and a y pair make a point, a coordinate pair, an ordered pair, right? An x comma y. Plot this ordered pair. Reflect the ordered pair. Because most absolute values have how many answers? 2. If it's one answer on the left, it's one answer on the right. Step 3, repeat step number 2 with a value 2 spaces away from the vertex. We're going to apply this. Ready? You've got 3 steps now, granted. Step 2 is a 3-parter, right? And step 3 is repeating step 2. But it's algebra. It's just application of our algebra skills. Okay, let's practice graphing. Remember, you can reference those rules as we're going. Graphing practice. Oops. Okay, the parent function, it's the OG function, right? It's the original function. It is the function, it is the graph, it is the equation that all other absolute value equations are compared to. Right? It's the beginning. Every time I say, man, how is that different from the parent function? This is the graph, this is the picture. It's the most perfect absolute value graph. This is our parent function. Y equals the absolute value of x. There is nothing about this that has any additions, any bells or whistles. There's no glitter added to this one. This is plain and simple. If you were going to go and order a hot dog, it would be the most basic one, right? No frills. Depending on who you are, it might be a ketchup hot dog, it might be a mustard hot dog. But none of that fancy stuff added to it. This is the parent function. This is what we will always compare it to. So let's talk. Let's identify in the beginning the M, the B, and the C. The M, the B, and the C. Do you remember what the formula I gave you looked like? If you don't, remember, you can just find it right over here on the other side of your notes. What's the M, the B, and the C? Let's first start by identifying. Remember, identification is the best because it's super easy. It's just there. M, B, and C. What's my M value in this original function? 1. 1x. Mx. What's my B value? Is there anything being added inside the absolute value? Nothing. And outside of the absolute value, what's being added? Nothing. It's pretty basic, right? No frills. So let's find the vertex. My vertex formula, negative b over m, comma, c. My vertex formula, negative b over m is my x value. C is my y value. So we're going to substitute negative b, negative 0, over m, 1, comma, 0. So what's my vertex? Can you simplify? What's negative 0 divided by 1? 0. Comma. 0. My vertex is 0, 0. What's that called? The origin. Good. So let's graph it. Underneath this guy right here, we're going to draw a graph I'm going to go 5 and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And my vertex, 0, 0, right there. Step number 1, find the vertex, plot it. Done? Find the vertex using that formula, plot it. Step number 2, on the other page of our notes. Step number 2. Step number 2, what do I do?
Pick an X value one space away from the vertex.
Okay, so I'm going to pick an X value. You could pick any one you wanted. If you wanted to pick 32 because 32 is your favorite number, go for it. Your graph has to go to 32 though. It's a whole lot easier to pick one space away from the vertex. What is one space away from my vertex? I could either use 1 or I could use -1. It's your choice. Let's live on the wild side. Are you ready?
Yep.
We're going to pick -1. That's what I'm going to use. So that means I'm going to substitute this right in up here. Instead of the variable x, I'm going to remove the variable x and I'm going to put in the number -1 because that's the number that I picked. Y equals the absolute value of -1. Y equals the absolute value of -1. What is the absolute value of -1? So y equals 1. Making my ordered pair, my x value was -1 and my y value was 1. After I substitute my x value, I simplify, I solve it, I figure out the answer, and that answer is my y. X and y make an ordered pair. Let's plot it. -1, +1. And what am I going to do now? I'm going to what? Plot the reflection of it, right? The opposite. Look, this is one space away from my vertex. I'm going to flip it over and make it one space away on the other side. Am I making a V shape? Okay, let's do it again. Step number 1, plot the vertex. Check. Step number 2, pick a number one space away. Substitute, get an order pair, plot it, reflect it. What's step number 3? Repeat it, but with 2 spaces away. So if I'm here at my vertex, what are my choices for 2 spaces away? +2 and -2. Let's do +2 this time. X equals 2. And I'm going to substitute that into my equation. Meaning y equals the absolute value of 2. Y equals the absolute value of 2. So y equals 2. Making my ordered pair, what comma what? +2, +2. Over 2, up 2. And reflect it. It's 2 spaces to the right. I need to make one 2 spaces to the left. And this is the most perfect, pristine, untarnished, original, absolute value. Isn't it beautiful? It's everything you could ever want in an absolute value. All right, you work through this at your tables.